All right, we're going to review for your Chapter 3 test here, and here's the review with the answers. First one, these lines do not need to be parallel for alternate interior, alternate exterior, corresponding, or same side interior angles. When you want those angles to be either equal or same side supplementary, that's when the lines have to be parallel. But you don't need parallel lines for alternate interior angles. For angle 3, the alternate interior are 5 and 13. Inside the two lines, and on opposite sides of the transversal. For angle 4, alternate exterior, for angle 6, alternate exterior is 4 and 12. Opposite sides of the transversal, outside the two lines. Opposite sides of the transversal, outside the two lines. For corresponding, angle 8, it's 4 and 12. If you notice, we're going to the bottom left here, so I get this vertice, bottom left, this vertice, bottom left, and they also have to be along the same transversal. That's why 8 and 16 are not corresponding. They're both bottom left, but they're not along the same transversal. And finally, same side interior angles to angle 14 are 3 and 9. So angle 14 is here, 3 is inside and on the same side of the transversal, and 9 is on the inside of these two angles and on the same side of the transversal. Page 2, we're trying to figure out which lines are parallel. So in this picture, my corresponding angles are equal. Now, when you want to figure out which lines they're dealing with, we're going along a transversal of A and sides C and D. Basically, B is the one side. If I eliminated it, I'd still have these two 32-degree angles. So therefore, I'm left with angles that are 32 degrees created by sides A, C, and D. Well, obviously, C and D have to be the parallel side since A intersects both of them. Also, 32 and 33 are not equal, so therefore A and B could not be parallel. Here, alternate exterior angles are equal, and they're along transversal C, which means A and B are parallel. D has nothing to do with the two congruent angles here, so the sides that are parallel are A and B, and it's by alternate exterior angles. Here, if same side interior angles are equal, that really doesn't matter. That doesn't help. But when same side interior angles are supplementary, like we have here along transversal C, that means sides A and B are parallel by the same side interior angles there. Okay. The next one we could say corresponding or alternate exterior. These are corresponding angles. These are alternate exterior angles. So therefore, we're along transversal D. So therefore, A and B have to be parallel. Side C has nothing to do with those angles. As we move it along, vertical angles are equal and linear pairs always add up to 180. That's true, but that has nothing to do with parallel lines. So nothing can be concluded as parallel here. Here, my alternate interior angles are equal. They're along transversal B. Side A has nothing to do with it, so sides C and D are parallel by alternate interior angles. Here, we have what we call same side exterior angles are equal. That doesn't matter. There's no rule about same side exterior angles, so therefore these lines we can't conclude are parallel. And finally, C and E are parallel because C and E are both perpendicular to line A. Anytime two lines are perpendicular to the same line, the lines are parallel. Now we're going to do some algebra, and I want to make a good decision here. Okay. In this case here, my x's represent alternate exterior angles. So when I set them equal, my x is 15. And when I plug 15 in for x, that makes this angle 106, which would make this angle 106, which makes this angle 74. If this is 106, the corresponding angle is also 106. So we set 15, z minus 1 equals 74, and z equals 5. 4y plus 6 equals 106, and my y equals 25. Here, my two y's represent same side interior angles. So I need to add them together and set them equal to 180. When I do that, my y equals 7, and I plug that in, I get 71 here, I get 109 here. 109 and 12z plus 1 are corresponding, so 109 and 109. And these two angles are corresponding as well. So I can set 20x minus 11 equal to 109, and 12z plus 1 equal to 109, and I get x and 9. X equals 6 and z equals 9. Next page, same deal. corresponding angles are equal, so I set my 18z plus 34 equals 25z minus 1. When I solve for my z, I get z equals 5. And when I plug that in, both these angles are 124. Linear pair here, that's 56 degrees. 124, and this is corresponding 124, so the linear pair makes this 56. So I set 5x minus 4 equal to 56. Gives me x equals 12, and 3y plus 8 equals 56, and my y equals 16. On this final one, I got to get the x's congruent here. Well, how do I do that? I'm going to say 8x plus 3 equals this angle right in here. And this angle right in here is corresponding to this angle right here. So by 2 steps, I could set 8x plus 3 equal to 11x minus 21. There's nothing saying there are in one step, but I can use alternate exterior angles and then corresponding angles to say they're equal. When I set them equal, my x equals 8. When I plug 8 in, my angles are 67 and 67. Therefore, the linear pair makes this 113, and the alternate exterior angle makes this 113. So therefore, 8y plus 5 equals 113, my y equals 6, and 9z plus 14 equals 113, and my z equals 11. Finding the steepness of a line, if you notice, and I'll ask you to do this on the test, the bigger the absolute value of the slope, that line goes on top. That's how I know it's steep. Okay? When I don't cross a y-axis at an exact point, I need to use its slope, which in this case is 3/2, and pick a point on the line. I picked 3/2 and 0.15. And now I solve for my b. I put 5 in for y, equals my slope of 3/2 times 1 plus b. We get 5 equals 3/2 plus b. I multiply everything through by 2. 10 equals 3 plus 2b. 7 equals 2b, and my y-intercept is 7/2. And it certainly looks like it as well. So the equation is y equals 3/2 x plus 7/2. With the negative 2/3 for a slope, which is the other line, a little less steep, because 2/3 is not as big as 3/2. I use that slope and I pick a point. I pick negative 1, 2. So 2 equals negative 2/3 times negative 1 plus b. 2 equals 2/3 plus b. We multiply everything by 3. 6 equals 2 plus 3b. 4 equals 3b, and my b is 4/3. And if you look at where this crosses the y-axis, it looks like it's 4/3. So my answer is y equals negative 2/3 x plus 4/3. With the parallel lines, it doesn't matter which one you put on top, because their steepness would be equal. I'm going to work with this first one down here, the AB, because that's a y-intercept I need to find. My slope is negative 5/3, up 5, left 3. And I pick point 1, negative 5. So negative 5 equals negative 5/3 times 1 plus b. Negative 5 equals negative 5/3 plus b. Multiply everything by 3, we get negative 15 equals negative 5 plus 3b. We add 5 to both sides, negative 10 equals 3b, and my b is negative 10/3. And it looks like it's about right here as well, right below the negative 3 spot on the y-axis. So my answer, y equals negative 5/3 x minus 10/3. Remember, whenever we find the equation of the line, in the end, we need to be able to plug in the slope and the y-intercept. Finally, the last one, I actually have an exact point for my y-intercept, so I can use it. It's 5. My slope is negative 5/3 x plus 5. If the exact point is on the y-axis, you can just take the point right off the y-axis without doing the extra work. When you have a vertical line, it's x equals, so this line is x equals 4. 1, 2, 3, 4, and it's x equals 4, because every point on that line has the x coordinate of 4. Here we get y equals negative 7. Every horizontal line is a y equals whatever y-intercept it is. In this case, it's negative 7, because every single point on this line has negative 7 as a y coordinate. Now to find the equations of a line. When you're given a slope and a y-intercept, it's pretty simple. We just plug them in. Y equals negative 4/3 x minus 2. And this is the one I'll ask for standard form on. We're going to move the x's over, so the x and y are on the same side, and we need to get rid of every fraction. So if I multiply everything by 3, I get 4x plus 3y equals negative 6. And that's my standard form of that equation. On the test, I'm only going to ask on the one where I give you y-intercept and slope to find the standard form as well. The rest of them, you can solve for y and just put them in y equals mx plus b format. So every other one, you're going to have a slope and a point. Now sometimes, like this first one, I give you the slope and the point. Sometimes you're going to have to find the slope or find a point. In this case here, when I give you the slope and the point, we plug the point, the y coordinate of the point in for y, -3, the slope in for m, -3/4, and the x coordinate in for x, which is 8. And we're always solving for b. -3/4 times 8 is -6. I add 6 to both sides, and my b is 3. When I write my answer, I always put my slope back in. Y equals -3/4 x plus 3. When I'm given 2 points, as I am here, I need to find their slope first. 2 minus a -3 over 5 minus a -1 is 5/6. And I could have just as easily done -3 minus 2 over -1 minus 5. I would have gotten -5 over -6, which is still 5/6. So I have a slope and I pick a point. I happen to pick 0.52, could have just as easily picked -1,3. So when I pick 0.52, 2 goes in for y, 5/6 times the 5 in for x. We get 2 equals 25/6 plus b, and when I multiply everything by 6, it eliminates my fraction. 12 equals 25 plus 6b, -13 equals 6b, and my b is -13 over 6. So y equals 5/6x minus 13 over 6. And our final answer, we always put our slope in front of x, and our y-intercept is a constant on the outside. Second one, same deal. -1 minus 6 is a -7. 4 minus -5 is a 9, so my slope is -7/9. I choose point -5/6. So 6 equals -7/9 times -5 plus b. 6 equals 35 over 9 plus b. We multiply everything by 9, and we get 54 equals 35 plus 9b. Subtract 35, divide by 9, and we get 19 over 9 for b. So my answer is going to be y equals -7/9 x plus 19 over 9. Once again, just plugging that slope back in. Now I could also ask this, and we need to know parallel lines have the same slope and perpendicular lines have opposite reciprocal slope. So if I want a line parallel to this given line in standard form through this given point, I've got to first solve the equation of the line I'm given for y. Subtract 4x, divide everything by 3, and we get y equals -4/3 x plus 3, which means my slope is -4/3. Now I have a slope and a point. So 2 equals -4/3 times 3 plus b. -4/3 times 3 is -4. So 2 equals -4 plus b, and my b equals 6. Therefore, y equals -4/3 x, my slope, plus my b, which is 6. Finally, we want to find the equation of a line perpendicular. We still find the equation of the given line in standard form that we have. 2x minus 5y equals -10. -5y equals -2x minus 10, and we divide everything by -5. Y equals 2/5 x plus 2. But we don't take that exact slope, we take the opposite reciprocal slope. If the slope is 2/5, the opposite reciprocal is -5/2. So I plug -5/2 in for my m. I plug 6 in for my x coordinate, and -2 in for my y coordinate. -5/2 times 6 is -15. So -2 equals -15 plus b. We add 15, we get 13, and my b equals 13. Therefore, my answer is going to be y equals -5/2 x plus 13.